So this is section 4.4 part B, and we're still going to be solving logarithmic and exponential equations. But if you notice from the previous part A, all of our answers turned out to be very nice integer values. Maybe a fraction, but for the most part integer values. So with part B, our answers are not going to turn out to be so nice. So we're going to have to write something what we call an exact answer, and that means we get x by itself, but do not touch your calculator. And then we're going to approximate the result to 3 decimal places. So I'm going to ask for an exact answer, and then you're going to approximate with 3 decimal places. So they're not going to be nice integer values anymore. So we still need to go through and make sure we understand which ones are exponentials and which ones are log equations. So number 1 is an exponential, so we should look at strategies 1, 2, 4. Number 2 are exponentials, and again we should look at 1, 2, and 4. Number 3 is exponential, and we should look at strategies 1, 2, and 4. Strategy 4 is a logarithmic, so we should look at 3, 5, and don't forget the asterisk. The asterisk says check your answers. And then number 5 is also a log equation, so we need to look at 3, 5, and asterisk on our strategies. Again, I'm not going to ask you what strategy you're using, but it's good to write this down and look back and go, okay, what strategy should I try? So when we're asked for an exact answer and then an approximated answer, most likely strategy 1's not going to work, because strategy 1 would mean we could have the same base, and that would probably turn out to be a nice integer or fraction value. So we probably need to stick with strategy 2 or 4 for any time they ask for an exact answer and then an approximated answer. So I'm going to go ahead and do strategy 2. Strategy 2 says do the circle by changing exponentials into log. So we get log base 10 of 5 equals x. Now, from previous sections, we know that we don't have to write base 10. If it was some other base, we would need to write it, but we could just write log of 5 equals x. Now that is an exact answer. I've gotten x by itself. I have not touched my calculator, so x is log 5. Now again, it is base 10, so we can just use our calculator and do log 5, and so we get approximately 0.69, and it did say round to the 3rd decimal place, so 0.699. So for an approximate, you're going to say x is approximately 0.699. So make sure you understand what it means to be an approximate and what it means to be an exact answer. Alright, so let's look at number 2. Again, strategy 1 probably is going to be out most of the time when they want an exact answer and an approximated answer. Since we've done strategy 2 quite often, let's go ahead and try strategy 4. Strategy 4 says take the log of both sides, but because I have an e, I'm going to choose to take the natural log of both sides. So again, when you have the e, you probably want to do the natural log and not just the log. Now why do we take the log of both sides? Because then our powers can come down in front. So we get 5x times the natural log of e equals the natural log of 2. Look back at your properties. Your property says the natural log of e is just 1 because they're inverses of each other. So that just goes away and we get 5x equaling the natural log of 2. We've got to still solve for our x, so we're going to divide by 5. So the exact answer is x equaling the natural log of 2 divided by 5. Now, be careful. You're only going to plug in the natural log of 2 into your calculator. Then whatever that answer is, we're going to divide by 5. So that's the exact answer. And then what's the approximated? Well, let's plug this in. So if I want to do the approximated answer, I would take natural log of 2, close the parentheses, log of 2, and then we're going to take that answer and then divide by 5. So we get approximately 0.139. So x is approximately 0.139. Alright, so again, number 3 is exponential. Strategy 1's most likely out, so let's think about just doing strategy 2. But before we do anything, we have to get in a sense, the exponent by itself. So we need to get rid of the 8. So don't multiply 8 times 3. 3 is being raised to a power, so you can't multiply the 8 in. But you can divide by 8 to get 3 to the 6 minus x by itself. And 40 divided by 8 is 5. So now I'm just going to go back to strategy 2. Strategy 2 says do the circle. So you're going to get really good at doing the circle. Practice it. Log base 3 of 5 equals 6 minus x. Now that is not considered the exact answer yet. You have not gotten x by itself. We still need to solve for x. So I'm going to subtract over the 6. And so when I do that, I'm just going to put that in front. So let's come up here. Negative 6 plus log base 3 of 5. You can put the negative 6 at the end. Just make sure you don't put them together. You can't put a negative 6 and a log base 3 of 5 together. And that's still going to equal negative x. So we still need to either multiply everything by negative or divide by negative. And so I'm going to flip it and multiply by negative. So you end up with 6 minus log base 3 of 5. And that is considered exact. Again, my math lab might want you to use natural log. So you're going to do change of base and put that into natural answer. Do your change of base. This is log 5 divided by log 3. So you're just going to do 6 minus log 5 divided by log 3. So 6 minus log 5 divided by log 3. The calculator will read it correctly because it will do the division first and then it will subtract. So we end up with approximately 4.535. Again, other ways to do it, other strategies to try, but x is going to be approximately 4.535. That is your approximated answer, and this was your exact answer. Again, my math lab might want you to say natural log instead of log, so you do 6 minus natural log 5 divided by natural log 3. That would be the exact answer. All right, number 4. We have one log, and if we have one log, we're going to do the circle. That's the only option we have. So strategy 5 is out. Strategy 3 says do the circle. But you have to know what ln has a base of to do the circle. Well, ln has a base of e. So e to the 5th equals x minus 4. So e to the 5th equals x minus 4. That is not the exact answer yet. You have not solved for x. So I need to add over the 4. So e to the 5th plus 4 equals x. And that is now the exact answer because you got x by itself. Then we're going to plug that into our calculator. So yeah, bring up the e and then raise it to the 5th power and then add 4. So we're going to get approximately 152.413. So the approximated answer is x is approximately 152.413. Make sure you know the difference between an exact and approximated. Now don't forget we have this asterisk. I would definitely highlight any log equations so you know that you still always have to check your answer. So when I plug in a 152.413 and I subtract 4, still going to be positive, so I'm okay with that as keeping it as an answer. All right, so now let's look at number 5. Number 5 is again log. We do have two logs, but the problem is they're not on opposite sides. So strategy 3 is still out for now. Now, what do we need to do? Well, we need to condense. Condense says, well, addition with a log. So we're going to condense the logs on these sides. And again, addition would condense back into multiplication. So log base 10, which is nice. So you can write base 10, but it's already understood to be there. X times x plus 9 now equals 1. 3 really is the one we want to use because now I have one log. So strategy 3 does work. It's actually 5 that's not going to. Some students want to do log strategy 5 because they see two logs, but they're not two logs on opposite sides. They're on the same side. So when we condense it, we're back into strategy 3. So we definitely need to do the circle. And how do we do that? We start off with our base, and our base is 10. So 10 to the 1st equals that. Plus 9x. All I did was distribute in my x. Because this is quadratic, I should make it equal to 0. So I'm going to have 0 equaling x squared plus 9x minus 10. I'm going to do the factors of negative 10 add up to 9. So it would be x plus 10 times x minus 1. Set each one equal to 0. I get x equaling negative 10 and x equaling 1. because we had the log equation, we definitely want to make sure we check our answers. That's what that asterisk means. So when I plug in a -10, putting in -10, we can't use it. So that's considered extraneous. When I plug in a 1, log of 1's fine. When I plug in a 1 here, 1 plus 9 is 10, that's fine. Again, don't throw out negatives just because they're negative. Don't keep positives just because they're positive. You plug it into the original equation, that's a log equation, and see if it works. So x equaling 1 is okay to keep. So we're going to get into some word problems in section 4.5. So let's go ahead and kind of veer into that by doing one application problem from 4.4. Now 4.5, the application problems are in your book. So I want you to print off page 529 to 531, and then we will go over those from your book. So make sure you print off those pages so you have them. For a $1,000 investment to double at an interest rate of 12% compounded continuously. All right, so back in 4.1, we know the formula to use for compounded continuously. It was A equaling PE raised to the RT. And then we labeled our parts. The principal amount was $1,000. The rate is 12%, so 0.112. You're compounded continuously, and you want to find the time. So you're looking for T, so somehow we have to know A. Well, the only piece of information I haven't used is we want the investment to double. So if we want our investment to double, what would A need to be? Well, we started off with 1,000, so if we wanted it to double, our A would be 2,000. So sometimes they're not going to give you the amount outright in a number form. They might tell it to you in words. So we have 2,000 equaling 1,000 e to the 0.12 times t. So now we're just back to an exponential. And if we're back to an exponential, we could do strategy 1, 2, or 4. Probably 1's going to be out. Let's try 2. What does 2 tell us to do? Well, change it into a log. But before we do, we need to get the e by itself. So we need to divide by 1,000. So we get 2 equaling e to the 0.12 t. Now, if you don't like the 2 on the left-hand side, you can flip it over to the right-hand side and do the circle that way. Or you can do backwards. It doesn't really matter. So we do log base e of 2 equals the exponent. So log base e of 2 equals 0.12 t. Now we don't ever call it log base e. What do we call log base e? We call it natural log. So natural log of 2 equals 0.12 t. And we still got to get t by itself, so we'll divide by 0.12. So we'll take our calculator and we'll do the natural log of 2. Natural log of 2 divided by 0.12. And we end up with 5.776, so forth. And does it say where to round to? Not this one. Let's just go round to the whole year. So the first whole year would be t approximately 6 years. So if we wanted a $1,000 investment, we would need to have 6 years for that to happen. So that is it for the second part. Again, know what it means to be an exact answer compared to an approximated. On number 5, we only had an exact because x equaled 1, so there was no reason to approximate. But on all the other ones, we needed to get the x by itself and let it be by an exact answer. And then we plugged it into our calculator to find the approximated.